Day 80. Looking at some tough U sub problems, or tougher. I don't think this first one is overly tough. But the next two are pretty challenging, and actually they're not both going to be U sub. Really, the tough U sub is the third problem we're going to look at today. Okay, so let's say we had this problem. It's a definite integral from 0 to pi over 2 of sine to the 6th x cosine x dx. So when we take a look at this problem, I have no idea what the integral of sine to the 6th x, right, cosine x dx is, right? That's not one that jumps out at me as I know the answer to it. But do I see anything whose derivative shows up elsewhere? Well, the nice thing is sine's derivative is cos. So some people might say, let's make u sine to the 6th x. We don't want to do that because the derivative of sine to the 6th x is a chain rule and it gets really ugly, and it would be 6 sine to the 5th x times cosine x. We don't want that. But we can just let u be sine x. I want u to be sine x instead of u to be cosine x, because then I can sub out sine to the 6th x with u to the 6th, right? And I don't have to worry about that 6th power. I'm never going to account for it in my u substitution, but I can do the integral of u to the 6th. So if we see this, I'm going to choose u to be sine x. The nice thing is du then just comes out to nice old cosine x dx, which is exactly what I have here. I don't even need to make an adjustment on this problem, which is awesome. Okay? So now I'm going to rewrite this integral. Since there's no coefficient, I don't need anything out front. I'm just going to put my du at the back. And that du is going to account for cosine x and dx. And then I have sine to the 6th x. I never accounted for that 6th power. What that literally means is sine of x to the 6th power. So I have u to the 6th. But I need to go ahead and change these, right? These are in terms of x, so I'm going to plug them in. Sine of 0 is 0, so 0 stays 0. Sine of pi over 2 is, right, that's right at the top of the unit circle, the point 0, 1. Sine is y, so this becomes a 1. These are equivalent integrals. So I get 1/7 u to the 7th for my antiderivative, right? Don't forget to bump and divide there. I'm going to put that 1/7 out front. Then I'm going to have 1 to the 7th power minus 0 to the 7th power. And I get 1/7 times 1, which is 1/7. Okay. Good. Let's take a look at the next one. This integral here looks like a classic u substitution problem, right? Let me show you how, if you gave me this problem when I was a high school student, here's what I would have done. And what I'm about to do is wrong, so don't put my mistake in your notes. Don't put this in your notes right now. So if I started this way, I've got a major problem right now. X dx, I do see x dx. But notice, this x is in the denominator. Right? What I really have here is 1 over x dx, which does not match x dx. This is all wrong. Okay? That is not how that problem will not work with u substitution. Right? And we're going to run into that problem right off the bat. So let me rewrite this problem and show you. So this is an incorrect method. correct method. U substitution is not going to work here, but I'm going to draw a shape that might lead you to the right answer. Now, we don't see these very often on AP tests, but I have seen them before. So if you're trying U substitution and it's not working, usually because you get something in the denominator that you don't want, see if you can see a heart and split it apart, right? If I have a binomial on top and a monomial on the bottom, I can split this. These are the same. This reduces. And I'm going to split my integrals here. Right? X squared divided by x is x. And I'm going to take that 4 out front. No U substitution needed. Now I've got two easy antiderivatives to do. This is my correct answer here. So if you're trying U substitution and it's not working, again, usually because you're getting du in the denominator or something like that, or you've got part of your du in the denominator, part in the numerator, it's always a strategy you can do. We can see the heart and split it apart. Okay? Again, this is not very common on the test, but it's a tough problem that if you can get it right, and a lot of other people don't, right? You can pass them, jump them, and score. Okay, here's the last one, which is a very difficult one. Now, here's the thing. This integral doesn't look that hard, but it is. I could make this so much easier if the denominator said x squared plus 5. If this was x squared plus 5, this is your classic U substitution easy problem. Okay? But it's not. U is x plus 5. The derivative comes out du equals dx, and I don't have any accounting for that x. Ugh. It's also a definite integral, so that doesn't help. So what can we do? Well, you may think, oh, let's see the heart and split it apart. But this is not a heart either because the binomial is on the bottom, not on the top. But what we're going to do here is we are going to combine U substitution with seeing the heart and splitting it apart. We're going to do a U substitution that puts it into the form of the previous problem. Okay? So watch what I do here. This is a little tricky. This is like if you're going for a 5, you need to know this method. There's a pretty good chance this won't be on the test, a problem like this, but it could be on the test. So we want to be ready for it. So watch this. I'm going to let u equal x plus 5. Du then equals 1 dx. Okay? Or I'll just write du equals dx. Okay? So when I rewrite this thing, I got my du at the back. Du is simply subbing in for dx. I've got my u on the bottom, but I never accounted for this x. And I also can't mix x's and u's. So watch what I'm going to do. Okay? I have an equation right here that I'm going to solve for x. And then I'm going to substitute that. It will be in terms of u now. So if u equals x plus 5, then u minus 5 equals x. So this, I can't put an x up here, but I can put u minus 5 because that's equivalent to x. Okay? Really tricky. I also need to adjust these bad boys. Okay? So I'm going to plug in 0 for x here. 0 plus 5 is 5. I'm going to plug in 2 down there. 2 plus 5 is 7. Okay? Not that this is, the only reason this is better than what I started with is because now I can do the heart. So I can do integral from 5 to 7 of u over u minus 5 over u. U divided by u is simply 1. So I got the integral from 5 to 7 of 1 du minus 5 integral 5 to 7 of 1 over u du. Okay? The antiderivative of 1 is u. The antiderivative of 1 over u is ln, absolute value of u. So I get 7 minus 5 minus 5 times ln 7 minus ln 5. 7 minus 5 is 2. ln 5 minus ln, or sorry, ln 7 minus ln 5 is ln 7/5. And this is my answer. Now, if you don't believe me that that's really the answer, let's take a look. Let's just do a little, check it on the calculator. I'm going to type my original integral in here. Uh-oh. Oh, great. Well, I guess that's not going to work. Let's just, I'll show it to you in class tomorrow morning. Talk to you guys later. 2 chains, bye.